All right, we're going to have a look at this one here today. So the deal on this is we got this weird looking bracket. We've got the load P at point C. We've got the pin joint at B. We've got that roller at A. We've got the dimensions on that. We're going to push on the bracket with P. And what we want to know is that if, do we want to know? We want to know, don't we have a limiting factor on this? I can't read the thing. Oh, there we go, 3,000 newtons. So the pin joint at B can only handle 3,000 newtons. All right, so given that, what I'd like to know is how much load P can you apply before that pin joint force exceeds 3,000 newtons. So here in class, find somebody to work with. You know, you could always go on the forums, those of you that are online for working together on this. So the first thing to do is to make that sketch into a practical, straightforward free body diagram. So that's step one. Maybe show it to me once you got it. And then from there, start to figure out the problem here. So take that sketch there, turn it into a free body diagram. So we got that load P at C. We've got the pin joint at B and a roller at A. And what we want to do is to figure out how high P can go before the pin at B has a force of 3,000 newtons in it. Okay, so that's the job here today. For those of you online, I'll kind of pause this recording so you're not just listening to nothing there, okay? So I'll do that. But so why don't you, those of you online, pause the recording and see if you can get a free body diagram of that drawn, then check back in, okay? Okay, a couple of questions have come up. Yeah, that point 1 there, that's from the corner to B, and then the point 4 is from B to C. Also, the questions come up if the center of the circle is above the corner. There's a two-part answer to that. The first part of the answer is yes. The second part of the answer is given you have the angle and this angled distance, you should be able to determine that that is the case because you've got enough information there to figure that out. Okay, so we want a nice, simple, direct free body diagram. Focus on the connections, replace those with forces. Remember the angle down there at the ramp. And then get nice simple dimensions that tie this thing together, okay? So that's what you want to be doing. So the thing to do with this is to cut the loop off. So really what you want are those dimensions there. So that's what you want to figure out. That and that. That way you've got A, B, and C connected in the X and Y directions, and that will help you get the moment arms. That's really how you want to approach this. So essentially you want to cut that loop off. Do the trigonometry on the angled line, do just a little bit of geometry on the semicircle, and based on that come up with a nice clean right angle bracket there basically that connects A, B, and C. All right, so when you do the trigonometry on this line right here and then do the little semicircle and then come on down, what you're going to end up with is 0.6 meters there. And from B to this corner is 0.3 meters, okay? So that's what you should come up with for a free body diagram for the dimensions. Now for the forces, what you're going to have is RBY, RBX, and then RA. Now RA will make a 60-degree angle with the horizontal. So, okay, so there's a free body diagram, right? So we're going 0.4 from C to B, 0.3 from B to the corner, and then 0.6 down to A. And we've got X and Y, B reactions there, and we've got a 60-degree angle on RA up left. We all there? Okay. Now the next deal on this is you got to start throwing equations at it. There isn't a nice little clean, I can just run this formula and solve it kind of thing. This is a little messier. Just start generating equations, the standard statics equations. Then think a little bit about B. You've got RB total is 3,000, right? That's your key to kind of working through that. But look at how RB is set up. You know, you got to RB. There's a little that gets a little messy there. Actually, generating an equation for RB because there's RBX and RBY involved with that, right? So that's going to get a little messy, perhaps. It's not going to be real clean, but you know you can work through this analytically. Another way you can do it once you generate those equations, you know, that I like to do at work and stuff is something like that, where I just link the equations together. I get the stuff kind of linked, walking through, and then once I have that done, where I kind of link one cell to the next with these equations, I can just throw in different values of P and see what comes out. I mean, P is obviously greater than 200, right? Let's see, protected view. File. I've got some problems here. I mean, oh, come on. I don't know if it's going to let me enter in a new value here or not. I'm in protected view. Okay, well, anyway. All right, so the approach on this thing is to generate statics equations to get relationships between the different variables. The variables are RA, P, RBX, and RBY. You know that RB total is 3,000, but that gets a little tricky because RBX and RBY are at right angles to one another. So you have to think about how to relate RBX and RBY so that you get a total RB of 3,000. Okay, now something I was just talking to the class about is there's a lot of ways to solve this. You can do this analytically if you want. It's not all that difficult, perhaps, but you just use those statics equations to get those variables related to one to another. And if you want, you get to set up a spreadsheet. You know, because if you know P, you can find RA. If you know RA, you can find RBX. So you can just walk on down and link these together. Then you can start to put numbers in for P if you relate those variables together on a spreadsheet. So you could try different values of P and just see what the result is. So if I put 500 in for P, you see RB is too low. I could try 1,000. I'm getting there, but I'm not there yet. And usually what I like to do is called bracketing. I like to shoot high and low and see, you know, how close I can get. Let's try 2,500. That's too high. So I know I'm somewhere between 1,000 and 2,500, and I can just keep working, throwing different numbers in there till I get to RB as 3,000. So this is another approach to solving the problem here, okay? This will be due Monday. We'll cover it tomorrow in class.